Hey guys, welcome back. Today we're going to be unboxing, building, and doing initial prints on the Ender 3 version 2. So the Ender 3, the original Ender 3, needs no introduction. We've covered it on the channel many times, and I'm sure many of you are well aware of what it's all about. I'm interested to see the changes that they've made and showcase those off to you today. So without further ado, let's open this up and unpack. So much like the original Ender 3, the entire base is already pre-assembled, and then we'll just set up the gantry on top of that. We have a large screen, the extruder assembly, and the wheels that ride up the left-hand side of the uprights. So we have our bag of bits and pieces and a small little coil of test filament here. We're probably not going to use that. Scraper, assembly tools, and some zip ties for wire management. We have a tensioner. I believe this is the Xaxis Tensioner because the Y is already pre-attached. Spool holder. The other set of wheels for the upright. And two 2040 extrusions. These are the uprights. And in here is our lead screw. Of course, power cord, the Z motor, and the other part of the spool holder. So before I open the manual and read through that real quick and get assembling, I just wanted to look at the base and compare and contrast against the original Ender 3. For starters, we're not going to have a power supply sticking up on the side. The power supply is integrated into the bottom portion of the base there, and the power cord leads out the back corner over here where the strain relief and the wires coming out of the bed are. From the front, we now have a 40-40 extrusion that's supposed to be more stable, and just by twisting it, I can tell you it is. There was quite a bit of play at times. You know, obviously you're not doing this while you're printing, but there could be some play like that on the original Ender 3. On the front, we have this little handle here for a small tool drawer, which is kind of neat to make use of the space underneath the machine. I know a lot of people printed those anyway. And one more point of improvement is there's no fan on the top to suck, debris and filament remnants in when it's trying to cool the board. People would print little shrouds to stop that from happening. Well, it's much easier to just move the fan to the bottom, and then that's no longer a concern. So some quality of life improvements in addition to the Y tensioner just being a simple dial to turn to apply tension to the belts. That's nice in comparison to having to pull on a metal bracket and tighten it with an Allen key or something. They've got a nice shroud around the Y motor here that covers the end stop and the end of the motor itself. Again, small quality of life improvements. If you do have debris or pieces of filament, they're not going to get caught in the pulley there or in that mechanism. So now that I've kind of looked at that, we'll look at the hot end as we get assembling, and we'll deconstruct that. But I'm going to read through the user manual real quick, and we'll start attaching the uprights. So for the first step, we need obviously both of the uprights. So we've got two uprights, and they are not the same. You'll notice that there is a little hole here in the middle of this one. So take note of that. We also have two small screw holes at the bottom here, and that's going to be for the bracket for the Z motor, I believe. We also need an M5 by 45 millimeter screw out of our bag of assembly bits. And we're going to need the Z-axis limit switch. And sorry, we don't need one M5 by 45 screw, we need 4 of them. All right. So the upright with the 2 holes there is going to go on this side, opposite of the drawer, on the side with the control box with the USB outlets in the front, like that. And then these two screws with the lock washers on them, they're going to go up through the bottom of the base here and bolt into the bottom of the extrusion. If I'm careful, I might be able to do this on its side like this. And just be careful that you're not pinching either of these two wires here as you tighten this down. So I'm going to tighten them so that they're reasonably snug, but I don't want to fully tighten them down yet, just in case I need to make any minor adjustments. And I'm making sure that the side of the upright is flush with the side here so that it's squared up. And then we'll just do the same for the other side. But this one has these two holes here, and those holes are going to go facing inward. So if they were like this, that would be wrong. So they're going to be closest to the bed, facing inward there. Okay. All right, so step one is almost complete. We just need the Z limit switch here and the associated bracket, and this is going to get bolted on with the two screws and the hammer nuts or T-nuts that are already pre-attached. So just loosen those. And then they want us to put this like this, okay. So we're going to place this like this, I believe. Let's see. Yeah, that looks good. And just by looking down the slot as you rotate these quickly, you can see if the hammer nuts have spun and properly engaged the extrusion. You don't need a whole lot of tension on these. There we go. And we may as well plug it in. So the small cable here is the Z limit switch, and it's got little notches on it so that it only goes in one way. There. And then this will be for the Z motor, which will be on the back side here in a moment. So now we're going to assemble part of the Z motor and lead screw assembly. So the motor already has the bracket pre-attached. That's what we're going to bolt through to the upright here. And we have the coupler. It's already pre-attached as well. So all we need to do is slide the lead screw in there, make sure it's kind of bottomed out, and then get the right Allen key. There we go. And just make sure that this coupler is tight. Whoop. Okay, so that's not going anywhere. And if we spin it around, I don't see any wobble or anything, so that's a good sign. Both, you can roll the lead screw on the table to see if it's wobbling to make sure that it's straight, and then also once it's bottomed out in the coupler, we want to make sure that that's straight still. Then we're going to take these two M4 by 18 millimeter countersunk screws, and these are the ones that are going to go into these countersunk holes in that little black bracket at the back. And then the holes on the upright are actually tapped, so we'll just screw right into that. So as I pointed them out before, there's the two threaded holes that we're going to screw into. And because of them being countersunk, it'll basically like self-align as you tighten that down. And then before proceeding, you just check that the alignment is correct. The lead screw should be in line with the center of the upright. If it's not, loosen it and adjust that bracket accordingly until it is. So for the next step, we need this trolley with the extruder attached to it. We're going to need a belt, a coupler, the M4 by 16 millimeter screws, and the wrench, in addition to the X rail. So which one of these is for the X? One of these has two holes on either end that are kind of countersunk on the top. The other one has more holes along the inner side here. So the one with two on either end, this is our top rail, goes like that. So we'll set that one aside for later. And our X rail is actually this one here. So, simple first things first. Let's take the coupler and thread it into the end of the extruder. And if you're so inclined, you can snug it down with the wrench Don't go crazy because you are tightening it into plastic. All right, looks good. And then we will take this guy. So this little countersunk screw hole here is there to clear the head of this screw. Now, which side goes on this? If I line that up with that screw, we have a hole next to it, and that needs to align with the next holes here. There's 2 holes and 2 holes. If I used this side, there'd be no 2 holes right here for those. So, line that up like that. And then holding the 2 together, we need to unbag these screws. And they have lock washers on them as well. And we're going to use them to screw through from the middle of this bracket, from inside here. We're going to screw through the back of the plate and into the extrusion. Once you get them started, like hand threaded, then you can actually screw right through the back of the bracket, through those holes that align with the front ones to tighten them down. So now that I've got that assembled and tightened down, from an alignment perspective, I line up the top of the 2020 with the top of that bracket, so those 2 are completely flush, and then that way you know things aren't kind of off kilter. And we'll do the same with the other side as well. And actually, just give them a good snug down. It's kind of difficult with the small kit Allen keys to get good leverage to tighten those through those holes, but we'll make do. Okay. So before we go and install the other trolley, which is what I always want to go and do, we actually need to slide on the X carriage here with the hot end. So at this point, we can easily slide it on the front, and 2 wheels go on top of the 2020, 1 on the bottom, like that. If it is too tight for you to slide that on like that, the bottom wheel has the eccentric nut, so you can use that to loosen provide some slack between the bottom wheel and the extrusion to make it easier to slide on. And then just remember to double back and tighten that before you try printing. You can always check to see if there's any play in the hot end to determine if you need to tighten the eccentric nut there. Okay, so now that we have that slid on, we can install the other set of wheels, and we're going to do it very similar to the first. The head of that bolt goes into the countersunk hole, and then we're going to use the same screws to bolt through the back and into the threaded holes in the extrusion. Okay, and then I've made sure that the 2 are completely lined up so that they're flush. And now we can take both of these and slide them down over those uprights. There. Okay. So right here, there's this brass threaded little insert. And so let's just line up the Z rod there and thread it in by hand. Yeah, so things are a little bit tight. These wheels are a little tight. This should ideally kind of slide down on its own, but if there's a lot of pressure between these wheels and the uprights, it'll provide some friction. All right, just to get these pieces out of the way, I'll slide the PTFE tube into that coupler we screwed in earlier, and then the set of cords here tucks into this little kind of clip here at the back. Okay. Good. Okay. Now, we are supposed to route the belt. So the teeth need to be facing in at all times, and you can actually slide it, luckily, right underneath the wheels. Again, you might have to loosen the eccentric nut on the bottom if you don't have clearance. Alternatively, that's probably why they told you to route the belt before attaching the hot end to the X-rail there. And then just fish it on top of the toothed gear there. And then this goes like this through, let me show you on the back, actually. There we go. So now the belt goes like this. And there is a slit in these little fingers here. So tuck it in the slit like that. And then just give it a little tug on the other side. Great. So you want it to be bottomed out on the little brass ferrule or little pinched thing on the end of the belt. Okay. Then the other side, we don't have the idler on here yet, so we'll just loosely loop it around and do the same thing, slide it onto that finger. Okay, good. So now we're going to install the Xaxis Tensioner. Just unscrew this completely, whoops, and then the inner section comes out. To make this easier for me, I'm going to leave the belt unhooked right now, just make sure that it stays routed where it needs to go, and then take the cover with the large slit facing the back, so the flat front facing the front there, put the idler back in, and it's got a long bolt on it that will poke out the other end here. Right. One of the bolts that I use to attach the trolley to the X-axis, I wasn't supposed to at that time. So at this point, I'm just going to remove this because we need to bolt through the cover to attach the cover there using the same bolt. There. So place the cover back on like that, thread the bolt back through. Now we can slide the belt back through the finger, okay? And then use this knob to apply tension to that belt. Before I go too crazy, we should bolt through the front as well. So there is one more of these tapered bolts. Well, we've already slid the entire X-axis assembly onto the uprights. If you hadn't, that's when you would do this now. Check the tension with the eccentric nuts on those wheels to make sure they're contacting the uprights well. And we've already tensioned the X belt. May as well do the same with the Y belt. This one is already more than tight enough, so we'll leave that. Now they want us to install that top rail we talked about earlier, with the recessed holes at the top. And then we'll use those long M5 bolts. They are M5 by 25 millimeter. Not quite as long as the base ones, well, which they give you an extra of. A little bit smaller, but they still have the same lock washers on them. So if you remember at the beginning, I said don't tighten them fully. You know, they're snug, but not super tight. Now is the time when we're gonna double back and tighten the bottom ones at the same time as these top ones to make sure everything's kind of locked in and squared up. So everything up here should be nice and flush. It's good. And then I'll flip it maybe on its back. So if you are flipping the printer like I just did, just make sure you hold the bed so the bed doesn't slide and smack into the table on you. You know, it is glass. You don't want to shatter that before you've even had an opportunity to print. They've used really soft rubber feet, actually. I'm just checking those out. Okay. All right. Nice and smooth. The bed as well on this one doesn't need the eccentric nuts on those wheels adjusted. There's no play in the bed, and if you reach under and you spin any one of the wheels, the bed is moving back and forth. So they're all making, you know, good contact with the middle rail. I know in the past some printers have come with that extremely loose and the bed is shifting all over the place. If you don't tighten that, you'll have all kinds of layer anomalies where they don't stack up nicely on you. And I'm gonna peel off the plastic because I just can't wait. It's one of my favorite parts. So just be careful. I half expected these clips to be hinged like some others are, where there's a screw through one side of them. They're not, so they will go flying if you slide them off. But they're nice, low profile way of attaching the bed or the glass print surface to the heated bed, and a little more refined than binder clips. One more thing, we never did connect the Xaxis motor to the cable. You know, we did the limit switch, but not that motor. So now everything is connected except all of this. So we have 3 cables here, 2 long, like 2 wider ones and a short one. The short one is the X-axis limit switch, which is right here. And like all the rest, it has little notches on it, so you can only put it in one way. And then the other 2, they have these little labels on them. So we've got X and we've got E, right? E for extruder, X for the X-axis motor here. Now, one thing I'm surprised not to see, you know, there's a lot of quality of life improvements over the original Ender 3. One thing that is missing is a guide to keep the filament off of your Z lead screw. Especially if these things, you know, they're greasy, and then you get that on your filament and you're dragging that grease through to the print head. Also, you can end up kind of like shaving particles off of your filament and they build up here. So a lot of people will print little guides to just kind of protect them from the lead screw. Would have been a nice, simple little thing to have. They took, you know, went to considerable lengths to improve a bunch of other elements of the machine. But I'm just being picky as well. So we will do some wire management. We'll you know, zip tie these things, making sure that there's still enough slack for it to reach everywhere it needs to go. But for now, I'll just kind of leave it flopping over to the side. There is strain relief on the heated bed cables. So that's, you know, nice to see. We've seen that on the CR10 series forever and a bunch of other machines now. So I guess we need a filament holder at some point and probably a screen. 2 parts of the filament holder, same thing we've seen time and time again. And I won't get into a huge debate as to whether or not you should have your filament on top of the machine or not. That's what they're showing. That's how we're going to assemble it. They show you doing it like that. And we're going to need some T-nuts and some bolts to do so. So there's a bag of 2 T-nuts. And then we'll need the associated M5 bolts. They're recommending M5 by 8 millimeter. In our case, they happen to be silver. A moment ago, I was showing you, you know, it's going to go over here. It obviously doesn't go this way. The filament needs to come down the back of the extruder, so it's going to go like this. And then as you're tightening these screws, just look down the channel to make sure that the T-nut has rotated and is going to properly lock it in. Some finishing touches. On the top rail here, we have some caps here just to cover up the unfinished edge. You know, it's not anodized on the ends where they cut it. So here's another little upgrade people would print for a lot of different printers. It goes onto the toothed gear that feeds your filament in on the extruder. And it just sits on top. It is notched, so there's a flat spot on it that aligns with the flat spot of the post coming out of the motor, like that. And it's just an easy way to see if the motor is indeed rotating. And also if you're skipping steps, let's say you have a jam, you're trying to feed it too fast, etc., you'll be able to see this kind of twitch back and forth as it skips steps. So it's a quick indication that everything is working as it should be, that it's spinning. I did kind of skip over a step, but the order of these things isn't too critical at this point. We want to attach the screen. We've got a nice touch screen here. We're going to bolt it onto the side. So the 3 bolts for it are already pre-installed and they have the T-nuts tightened on them. So just loosen those, give you some play. And then this is going to go right over here. And in my case, I'm going to slide it right to the front. Sometimes if those T-nuts don't rotate and engage properly, I just loosen the screw and then quickly kind of spin it and it turns and locks it in. This front one you can't really see. You could pop off this cap if you wanted to see down the channel. And this does actually slide off. It's got these little T-posts here that slide into little keyholes in this bracket. And then obviously this cord goes into the back of the screen, and it is keyed, so it only goes in one direction, like that. So we've already done a double check of our wiring connections. We already attached everything here. We almost missed the Z motor earlier. We've obviously got our screen connected. The last thing that I would suggest that we do is double check that our power supply is at the right voltage. So right now it's set to 230 volts. And in our case, we're at 110, 120. We're not going to blow anything. If we plug it in and it's set to 230, it's just not going to turn on. If you're in Europe or somewhere where you have 230 coming out of your wall and that's set to 110, you're going to fry the power supply at the very least. So in their case, it's more critical than ours, but just flick it until we see 115. Great. And let's plug it in and see if it turns on. And then we'll be able to validate, the motion, X, Y, Z extruder. See that, we haven't missed any connections or anything. And then we'll go through a leveling process and be able to start our first prints. All right, so we plugged it in, hit the power button on the back, and it turned on. So we have a color screen. It's not a touch screen, so don't go poking around. But it's pretty easy to use the dial to jog through the menu options. Go to prepare, go to auto home. It's going to raise the Z, should home the X, it'll home the Y, and then it'll bring the Z down, home the Z. And I'm just going to keep my finger over here near the Z limit switch in case there's not enough clearance and the nozzle tries to ram into the bed. So now we need to level the bed. So we should probably heat it up and make sure everything gets up to temperature. We will go to prepare, and there's a menu option for preheat PLA. So we can just use the presets. At the bottom, we can see that the hot end is set to 200 and the bed is set to 60 degrees. So we'll wait until they get up to temperature. So now we're completely up to temperature. And I've made sure that we have, a little bit of clearance between the nozzle and the bed. And I've tightened each of the knobs on the four corners to kind of preload the springs. And so I'm just going to disable the stepper, and I can move it around by hand. And so I'll move it, a little bit in on this corner, slide a piece of printer paper underneath, and then adjust the knob until I have just a little bit of drag. And then slide it over here. Now when we are moving things around, especially the hot end, we don't want to put any downward force on it because the Z stepper is also disabled. And then that would obviously slide the whole X gantry down and screw up our leveling. And you'll want to go around probably twice. First time is kind of a rough tune. And every time you adjust one corner, you kind of impact the others. So it's nice to go around a second time to validate that everything is still truly level. Another thing you can do to make sure you don't scratch your bed as you're doing this is keep the paper under the nozzle as you move it from corner to corner. Because as I move it over here now, it's very, very, very tight. And I would have a nice scratch mark if I hadn't done that. All right, so let's grab a roll of filament, throw it on the spool holder up here, route it through the extruder, and do some test prints. All right, we're back a couple hours later anyway. And one thing that I didn't point out earlier that I realized when I was watching a print is how quiet it is. So it's on right now, it's heated up, the hot end fan is spinning, and you can barely hear it in comparison. And earlier when we were doing, checking that it would auto home correctly, you hear nothing. You don't hear that typical stepper motor whine or anything like that. So that's a huge improvement from the Ender 3, which you can hear easily from the next room over. And that's one reason I would upgrade the feet on an Ender 3 to something very soft and rubbery like these ones. That's not needed here, but it's still really nice to have. Anyway, We've got 3 prints. We've got a frog, that's an amputee. I broke his leg off, that's my fault, not the printer's. So we've got a little frog. We've got a Prusa Mini little bracket. And then we've got a typical XYZ cube. I had a little bit of bed adhesion issues. Again, not the printer's fault, that's mine, so it's curled up at the corner. So with that, hopefully you can assemble and get your Ender 3 version 2 printing at home. Remember to like and subscribe and ring that bell to get notified when we upload more videos like the Ender 3 version 2. Thanks for watching.